right, I came back to do a couple more problems on data assignment 3. I'm going to go over 14 through 16 because this is what we talked about in lesson 6.3 today. Okay, it says upload sample 3 into Statcrunch, then answer questions 14 through 16. Sample 3 was the one with sample size of 200. Okay, so you open up your Statcrunch and data load from file on my computer. That's where I save my file, not on the web somewhere. And I put all my folder samples in this folder. I'll just drag it over here and upload it. So just double check your number for me. You must have 200 student data in here. If you scroll all the way down, you should not see 25 or 50. Your number should go all the way down to 200. If you do not have that many numbers, that means maybe you did not reset as you were downloading these data files from census at school. So if all your files are a size of 25, you need to go back and download one that is a size of 200. Okay, all right, what are we doing with this? Let's read the problem again. So I uploaded the data. It says we want to construct a 95% confidence interval for the proportion for all students who take a car to school. Okay, so we're interested in whether a student take a car to school or not. So the number of success, I'll go ahead and start typing a little bit, and maybe you don't have to type all these information. The number of success is considered the number of the number of the number of students who take a car to school. Okay, the number of failure is equal to the number of students who do not take a car to school. So what we need to do is this. We need to confirm that both of these numbers are at least 5. Now, I know I want to change the font. Stop being so angry. In your Word doc that you probably downloaded, you probably have 15, at least 15. Change it to 5. 15 was a number that I used with my other stat classes previously, when the textbook edition had the number 15. But I checked out the 7th edition, and as we went over in class, we saw that the number is 5. So we need the number of students who... You don't need to scream. The number of students who take car to school has to be bigger than 5 or equal to 5, or the number of students who do not take a car to school has to be bigger than or equal to 5. Now remember, our sample size is pretty big. Sample size is 200. So I have a feeling we're going to be able to meet this condition. So let's figure out, well, look though, I do give you this mathematical notation, but this is what they're saying. Out of total n number of students, which is 200, p hat refers to the sample proportion. Like, what proportion of students take car to school? Instead of doing n times p hat and n times, well, that's really q hat, I will actually just find the raw numbers. Okay, the raw number being how many people take cars to school, right? So on my Statcrunch, I remember some of you guys did this by, so this is the column that we're interested in, aren't we? Please be quiet. Hey, you know what? I may be able to do this. I may be able to just sort this A, but it starts with B. See, you see, there's so many people who are taking car. What we can do is this, you guys. We can probably just create a bar chart. I'm going to do a graph, bar plot with data. And I'll just click on travel to school, how students travel to school. And I'll just click on compute. And they will give me a bar chart. If I put my mouse over this tallest bar for car, well, mine is the tallest bar. But who knows, maybe your sample is a little different and more students take, maybe more students are taking boat to school or walking to school, but my number is 97. Your number is probably going to be different, but you know, as an evidence of how I got that number, I think I'm going to include this picture in my Word doc. You can do it differently. You don't have to have a pie chart. Like Sabrina, who submitted this assignment already, she never did a pie chart. But as long as you figure out how many students are taking car to school in your data set, I'll be happy with it. I can see, what's the number? 97. The frequency is 97. 97 is definitely greater than, look at how I'm typing this for me. Okay, 97 is definitely, what's the greater than 5? So that is good. That part is good. Okay, next one. If 97 students take a car to school, how many of them don't, how many of the 200 students do not take a car to school? I can figure that out by doing a quick subtraction. There are 200 total number of students. 97 of them take car to school, so I just did Noah! 200 minus 97. So I got 103 students in my sample who do not take a car to school, and I see that this number is greater than 5 again. So what can I say? I get to do my confidence interval. So I found out that the number of success and, well, hold on. Both the number of success, which was 97, and the number of failures, which was 103, are both greater than 5. So I get to use the Z interval for population proportion. Oopsies. So that's my conclusion, or, well, that's my answer. And you guys can probably word this better, but I just need you to show me those numbers before you go on. Both are gonna definitely come out to be greater than 5, because I ask you to use the sample with the biggest sample size of 200. If it doesn't come out to be greater than 5, well, I want you to email me and let me know, okay? So that's how you can do the first part, just checking the condition by seeing the raw number of success and failure. All right, let's actually construct a confidence interval for the proportion of all students who take a car to school. All right, let's be careful over here. I'm giving you direction. I should highlight the whole thing. Okay, I should probably have this up and the same screen here. All right, let's do the confidence interval. You will go to stat, you will go to proportion stat and click on one sample and go to data, because we have a set of data, right? Click on data. And they're asking you which variable, which values. I want travel to school. But for success, type in CAR, capital C-A-R. You're telling them that we are specifically looking for a type of students who are taking car to school. So make sure you type in CAR with a capital C, and then tell them that we want the 95% confidence interval. So over here, I'm changing this to confidence interval for P. Level is 0.95. Just do the standard method, and I'm done. I'm gonna go ahead and click on compute. And I will copy this. So guys, when I'm grading your assignment, what I'm checking for is, are you using the correct sample? Like, hold on. If your output table over here does not say total is 200, then you did something wrong, right? If you use 25 or 50, then your sample size was too small. Also, you notice that the count is 97 here. They said the count is 97. That's the number of students who take car to school. This is good. So I got the confidence interval is from 41%, well, rounded up to like 42% to about 55% are, that will be the confidence interval to estimate the true population proportion. All right, so we should go ahead and finish this up. Let's go ahead and interpret this. So number 15 was just including this output table. So we're done. So finally, how about we write the standard sentence for interpreting the confidence interval to summarize your result. I think we have a standard sentence up here somewhere. I'm just gonna go and copy it, and I'll change the wording a little bit. Okay? Shh, quiet. Sorry, my house is so noisy. With 95% confidence, I can say that the population proportion of students of all students who takes car to school is between 0.4142, I'll just round it however I want, and 0.55, or Luna, stop it, 42% to 55%. You can include that if you want, because I think percentages are easier to say. But what we are estimating is the population proportion of all students who takes car to school, okay? And that is it. Okay, hold on. That is it for number 16. I'm gonna go ahead and stop this. I know, sorry about the quality of this video. It's a little bit noisy, but we went over 3 problems just now. If I can come back later to go over the rest of them, what's this? Number 5 through 15, I will. But this was pretty similar to what we did in class today. All right, I will talk to you later.